say easily, for example, tell me if person A enters this in this room. So this can be easily done. And you can already register yourself on the same machine. This is sputnik.congress.ccc.de and enter your user information at our desk. We are able to we can combine your tag ID with the information you provided to your account. So we want to make sure at least a bit that only person that is responsible for the tag can update it. And now Hannes will talk about the more interesting part, what can you do with the data and how it will look like.
Yeah, well, good day. I'm Hannes Wiener from Chaos Computer Club Berlin, hacker, Doom hacker. Yeah, I will talk about Sputnik middleware and visualization. Well, visualization was done by Adricom. Pavel will talk about it. So the problem I will cover is the middleware, so that piece of software. So we have here the RFID, the access points, which are talking UDP, Milos provided, and the middleware doing XML and talking to the visualization. So the basic design goals was that I receive some UDP data, UDP frames from the access points, convert them to XML, add some position information because the visualization needs to have positions to position their avatars. Yeah, and have a web interface for for correlating users to tags. Yeah, so the UDP datagram looks yeah, like that. There's first the originator, so the sending IP address of the base station, then how big it is, which protocol version used, then there are some flags, there's ACK, but more especially the button pressed flag. Then we have a byte of transmit strength, that's yeah, the transmit strength used by the access point. Then a 4-byte sequence number and a 4-byte tag ID. So that's basically what I'm parsing, and yes, as interfaces I have an XML stream at Sputnik Congress CCC.de on port 8000. It submits and receives observation with a given priority. So we have a priority level in the XML stream. So if you get /0, you get all raw information, all raw UDP frames converted to XML without any position information, only with who has sent the UDP frame. On information level 24, which is currently not available because we don't have yet the position data of the observers, you will get later observation with singularized position data. Yeah, and then there's a web interface for user tag correlation and overview. So the XML we use on the XML stream is observation. We have an observation, it has an ID, it has an observer, so who has seen this observation, an observed object, which is the tag ID or a URL with the tag ID, then a time, it's a double float encoded seconds.microseconds, then min-max distance, which are float values and which is a transmit strength translated to a float. Then a direction vector XYZ, which is currently not in use. Then a priority, that's 0 or 24 or 23 or whatever. Then optional position, so at level 0 you don't get any position information, but at level 24 you will get position information. Yeah, for the HTTP interface to get some useful data out of the tag ID, you can simply get at HTTP Sputnik Congress CCCDE/tracking users, and you get back an XML stanza. So you get back a tracking user response with the values anyone entered. So an ID, a name, an email address, a nick, a mugshot URL, a sex, and a role, and which talks he visited, and unknown visitor tag ID if there's no person, no user correlated to the tag ID yet. The same is true for observers. You can get /tracking observers, where you get back a list of observers with an ID, position, name, and type. Yeah, and basically the following applications are done by me. It's a position singularizer, which subscribes to the XML stream at level 0 and uses the observer data to add position information into the observations. Then a pentagraph matcher, which parses the pentagraph database and correlates if a user is 10 minutes in a room where a lecturer is, that the user has visited the lecture. Then also room lookup, so in which room the user was or wasn't the last time. And now I wanted to have a live demo. So I will just turn it to Sputnik. Okay, that's a live demo. All this stuff is written in an object-oriented, high-level programming language called Doom. So no C here, no buffer overflow C. So that's the live stream, what you currently see. You see observations from the observer, which his ID, which objects he currently sees, then a timestamp, a priority, min distance, max distance, and the direction. Direction is always 0 currently. And also, that's the basic stream, that's at level 0, so no position information yet. And the other thing is that one. That's the web interface. Once you connect, you get a list of users, a list of observers, a list of tags. So no observers yet, we have to fill in that. And here are some tags, and if I log in, users, so now I can edit a tag and correlate it to a user. So let us say that is Fubal23. Sounds okay. That was bad. Sorry? interface is on port 80 and the raw XML stream is on port 8000. Okay, and then I will switch over to Pavel, who will talk about the visualization. Yeah, okay.
Yeah, okay, just a couple of words regarding the visualization you can see downstairs. We choose to set up a virtual observation camera setup. So we have a 3D model of the DCC, which was provided by Martin, who was working on this model for years, I think. And we took the model and exported it in our proprietary XML format for our Y60 engine, and did write this application mostly in JavaScript with a few C++ modules to handle the avatar billboards. So we tested it with up to 1,000 billboards that can move simultaneously in the world, and hopefully this should work. We'll see. Okay, just a couple of words regarding why we did use this engine. First of all, because we know it, and it's an engine that is done to do special applications in a very short time. So actually, it's more 3D multimedia framework, and I think it took roughly, I would say, the order of 10 to 15 days to put everything together you see down there. Yeah. How does it work? It's quite simple. You've seen the HTTP stream. We just parse the stream, and if we see a new tag there, we create a new avatar. If a known tag is observed with position information, we animate the avatar to move to the observed position. So what you will see down there then is a lot of moving around, because we do randomize the positions within the estimated area. And if a tag is not seen for some time, in our case 30 seconds, then we silently remove it. We have a touchscreen interface down there where you can select virtual cameras. I think we have about 30 virtual cameras which look like or act like observation cameras, and you can select one and sweep it and look into all the different rooms, and then all the avatars running around are pickable, so you will be able on the touch screen to pick an avatar, and then it will retrieve the information associated with the tag ID if there is one, and also display the talks you have visited. Okay, so thank you very much, and all you have to do now, if you haven't done it already, buy one or more of these tags. I think it's fun to have more of them, to play with them, create your user ID, and come to visit us on our booth and get your tags associated. Thank you. Is there a mic somewhere here?